This is Ribin Chen, and this video shows my solution to question 8 of homework 7. Question 8 is a Poisson process defined by three properties. The equation or the formula of the Poisson process is equals to the probability of the n t1, t2 equals to k is equals to e of the power of minus lambda t times lambda t of the power of k divided by k. This one. And for the first question, which asks us to calculate the expected value of the xt, the stochastic process of the expected t. From the previous lectures or the homeworks, we know that the expected value of the Poisson distribution, assume x is the Poisson distribution variables, and the expected value of this distribution is equals to the lambda, which has already been proved in the previous lectures. And because of the third property that at a time moment t there is no more one Poisson point, therefore using point t I we form the stochastic process xt is equals to n0 t. We know that the expected value of the xt is equals to lambda t. The second question, the question B, asks us to find the correlation of T1, T2. Because there is no information that we only know that T1 and T2 is greater than 0, but do not know which one is larger. Therefore, first we assume that if T2 is greater than or equals to T1, therefore, by the definition, the distribution of the xt1 is equals to xt1 minus x0, which is defined by the property 3. And also we know that we can know that this is the xt2 minus xt1 is the one sample of the Poisson process, and these events are independent. So we calculate the correlation of T1 and T2, and it is equals to expected value of xt1, xt2. And we can extend the expression of xt2, which is equals to xt2 minus xt1 plus xt1. This is an identity. Therefore, it is equal to this, and we times this part with the xt1 and this part with xt2, which can be returned in the formula of this. And this is an add function. Therefore, because xt1 is equals to xt1 minus x0 and also xt2 minus xt1, these are independent, so it can be returned in this way. And we know that the expected value of the xt1 is equals to lambda t1, have already proved in question A. And similarly, these are equals to lambda t2 minus lambda t1. So we need to calculate the expected value of xt1 square. From the Poisson distribution, we can know that this equation, which is implies from the definition of the distribution, that the integral of the Poisson distribution from 0 to positive infinity is equals to 1. So we can know that calculate the deviation of lambda, and the left part is equals to this from this, and the deviation of this is equals to this. It is a function of the lambda. The deviation, this is a deviation of the lambda times e of the power of lambda. And we know that because k is limited to the positive infinity, therefore the k minus 1 is equals to k. Finally, and for this one, it is equals to 1 plus lambda times e lambda, and the e lambda can be transferred into the left part, and we know that we get this value. And also this expression is the expression of the expected value of x squared. Similarly, we can imply that the expected value of xt squared is equals to 1 plus lambda t times lambda t. Hence, the correlation of T1 and T2 is equal to lambda T1 times lambda T2 minus lambda T1 plus 1 plus lambda T1 times lambda T1. And finally, it is equals to lambda square T1 T2 plus lambda T1. Similarly, if the case is that T1 is greater than or equals to T2, the correlation is equals to lambda square T1 T2 plus lambda T2. Combine of the two cases, we get that the correlation of T1 T2 is equals to this, and it can be simply written in lambda times minimum of the T1 T2 plus lambda T1 T2. Therefore, the question 8 has been completed.